Alright, this video is about reflections and dilations, which we've worked on before, but in the past we stayed very basic. We just used the x-axis and the y-axis as the reflection line. Now we're going to get a little bit more advanced and use other lines. And when it's time for dilations, in the past we stuck to the origin as the center of dilation. Now we're going to be using other points as the center of dilation as well. So we're just getting a little bit more advanced with our reflections and dilations. First of all, understand this. When you see a small equation like this, like y equals a number or x equals a number, these are horizontal and vertical lines. Now, it's the opposite of what you might think, because you know that the y-axis is vertical, but the line y equals 1 is actually going to be a horizontal line. It's a horizontal line at 1. So this is the line y equals 1. It's a horizontal line at 1. Similarly, the line x equals -1 is a vertical line. It's a vertical line at -1. So this is the line x equals -1. So when you do your reflection across this line, just be careful to ignore the x-axis now. It's tempting to fall back on the x-axis as a common reflection line, but nope, got to use this new one. So if I want to find the image of point H, I'm going to go the same distance on the other side of the line. So this is 1 below the line, so I'm going to go 1 above the line, and that'll be my new point H prime. Okay. If I'm going to do my point E, this is 1, 2, 3, 4, 5 units below the blue line. Okay, so I'm going to go 5 units above the blue line. 1, 2, 3, 4, 5. And that's going to be E prime. Okay, look at point F. This is 6 units. No, yes, this is 6 units below the blue line. Again, it's so hard to keep yourself from counting from the x-axis, because that's what we're used to. So just be really careful to make sure you're counting. I almost made the mistake for a second there. So it's 6 units from the blue line. So now I need to go 6 units above the blue line, which is actually going to go a little bit off the chart, but that's okay. So this is 5 units. So 6 units is going to be about here. And this is F prime. And then the point L, that's 1 unit below the blue line, so I'm going to go 1 unit above the blue line. And now I'll just connect those dots. So there is your reflection across the line y equals 1. So let's do the same thing with problem number 2 here. All right, see how the point W is 2 units away from the blue line. So I need to go 2 units to the left of the blue line, and that's going to be the image. Point B, 1, 2, 3, 4 units from the blue line. So I'm going to do 4 units to the left of the blue line, and that'll be B prime. And then point R is 3 units to the right of the blue line, so I'm going to go 3 units to the left of the blue line. Okay, and now I'll connect the dots. All right, so there's your reflection, B prime, R prime, W prime. Next, we need to reflect across the line y equals 3, and a sketch might be helpful. All right, so y equals 3 is a horizontal line at 3. Let's do a quick sketch. Okay, so there is my y-axis and my x-axis. So let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, I'll put more marks on here if I need to. So the line y equals 3 is a horizontal line at 3. Okay, so this is the line y equals 3. Okay, now the point we need to reflect is the point 2 comma negative 5. Okay, so this is 2, 1, 2, 3, 4. Okay, so I need to go down one more. Okay, so here is the point 2 comma negative 5. Okay, now I need to reflect this point over this line. Man, I think I'm going to need more space in this. All right, notice how this point is 8 spaces below the line y equals 3. All right, this is a distance of 8. So if I'm going to do a reflection, I need to go 8 spaces above this line. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is actually at a height of 11, you know, because this is 3, and then I went up 8 more, so that's a total of 11. And don't forget that the x-coordinate is 2. So we're not changing that. We're still at an x value of 2. So this is the point 2 comma 11. All right, so there's your answer. Now, for number 4, we need to reflect across the line x equals 3, which is a vertical line. And we're reflecting the same point. So maybe I can use the same graph. Okay, so this time we are reflecting over the line x equals 3. So that's a vertical line at 3. So this is the line x equals 3. All right, so we have to reflect over this line. Okay, so 2 comma negative 5. Let me actually move this. It's in my way. Okay, I'll put it over here, 2 comma negative 5. So if I want to find the mirror image of this point, notice how this point is 1 unit to the left of the line. So that means I need to go 1 unit to the right of the line. Okay, so for that reason, this is going to be the point 4 comma negative 5. Okay, remember, this is the line x equals 3. So here we are at 3. If I go 1 space to the right, that's 4. And the y value is still the same. The y value is still negative 5. Okay, so that's how you reflect across a line that's not the y-axis or the x-axis. Okay, looking at problem number 5, we need to do a dilation by a scale factor of 3 over 2. Okay, now for number 5, we are using the origin 0, 0 as the center of dilation. So when the origin is the center of dilation, all you really have to do is use the coordinates. You know what? I'm going to use a smaller pen. So think of this as point A for a moment. So point A has the coordinates negative 2, comma 4. So that's negative 2, comma 4. So if I want to find out what A prime is, all I really have to do is multiply each of these by 3 over 2. So if I do negative 2 times 3 over 2, the 2's cancel out, all right, and that just leaves me with negative 3. The negative sign doesn't go away. Okay, so that means the x-coordinate is going to be negative 3. Now, if I do the same thing with the y value, if I do 4 and I multiply times 3 over 2. Okay, remember, this is like having 4 over 1. 4 times 3 is 12. 1 times 2 is 2. So that's 12 over 2, which is 6. So a prime is negative 3 comma 6. All right, so that's going to be negative 3 comma 6 will be right here. So this will be a prime. Let's do the same thing for what I'm going to call point B. Okay, if this is point B, then the coordinates of point B are 2 comma 2. So if I want to find out the coordinates of B prime, I need to multiply these by the scale factor. Multiply by 3 over 2. So if I do 2 times 3 over 2, well, okay, look, the 2's are just going to cancel each other out. So that's going to be 3. Okay. Oh, and they're both 2, so that's going to just give me 3 comma 3. All right, so the point 3 comma 3 is right here, and that's going to be B prime. So here is the line segment after the dilation. All right, so notice how it's parallel, but it's longer. Now, it's very easy when the center of dilation is 0 comma 0. It's a little tougher when the center of dilation is something else. Now, I teach a couple different methods of doing this, but I've decided that the easiest method is just to pretend. Pretend that the point that they give you to use as the center of dilation, pretend that that point is the origin. So let's see, 6 comma negative 4. Let's see, 1, 2. So here's 6 comma negative 4 is right here. Now, if this is the center of dilation, let's just pretend that this is the origin. So in that case, I'm going to have a new set of axes, like a new x and y axis. All right, so my new x-axis will be here, and my new y-axis will be here. So let's pretend. So based on this x-axis and this y-axis, what are the coordinates of these points? Okay, so this first point here on the left, okay, according to my new coordinates, my new axes, this first point is at, let's see, that's 6, 7, 8. So it is at negative 8. Hold on, I want to use a smaller ink. Okay, it is at negative 8, comma. And all right, if this is my new x-axis, then let's see, that's 4, 8. So that's positive 8. All right, so these are the coordinates of the first point based on my new x and y axis. Now, let's do the dilation. So since we're doing a dilation by a scale factor of 1/2, that means we're going to multiply everything by 1/2. So that's going to give us negative 4 and 4. And again, let's plot this point on our pretend set of axes. So negative 4 comma 4, starting from here, would be negative 4 comma 4 would be right here. So that would be my new point. Okay, let's do the same thing with the second point, which is right here. Based on my pretend origin, this point is at negative 4, comma, let's see, 4, 5, 6. So the second point is at negative 4, comma 6. All right, and now we're going to do the scale factor of 1/2. So that's going to become negative 2, comma 3. And we will again graph it on our fake graph. So pretending this is the origin, negative 2, comma 3 will be here, negative 2, comma 3. And so here you have it. If I go ahead and just connect these points, then that's it. This tiny segment is going to be the dilation of the original segment by a scale factor of 1/2 if the point 6, comma negative 4 is the center of dilation. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.